In order to differentiate this equation here to find dy by dx, what would you do? Well, you could use the product rule 11 times. You could give it a shot. I'd probably turn into dust before you make it halfway. Instead, we're going to separate the function and use the chain rule. So the formula for the chain rule is as shown here on the screen. The derivative of the outside function multiplied by the derivative of the inside function. So I find this confuses many students, especially when it's displayed in the formula booklet like this, because you don't really know what's going on, and it doesn't help you understand what's really happening when you're using the chain rule. So I'm gonna walk through this step by step. So our function is 7x cubed plus 2x squared plus 7x plus 69, all raised to the power of 11. And I'm going to write the 11 in pink here for a reason I'll divulge into later. So what the chain rule tells us is that dy by dx can be split up into dy over du times du over dx. So what does it mean to have the u on the top, the x on the bottom, the y on the top, the u on the bottom? So what does this all mean? So they say in respect to, but I find that to be a loaded term. I have no idea what they're saying when they say with respect to. The way I see it, simple function here, y equals x squared, and the derivative of this function, 2x. Where does y come from? This y is the output, and this x is the input. So what they're saying is, if you split up a function into terms of u, like, for example here, y equals 7x cubed plus 2x squared plus 7x plus 69 to the power of 11. If we instead call this part u, we can say y is equal to u to the 11th. And then we can say that u is equal to all this. And then now it's a bit easier to look at. So we would take the derivative of the outside function and multiply it by the derivative of this entire inside function. So what would we have? We'd have, so I'm going to write it out, d dx of u to the 11th times d dx of this inside function here, 7x cubed plus 2x squared plus 7x plus 69. So we can do both of these pretty simply with the power rule. Here we would get d dx of u11 would be 11 u to the 10th and multiplied by 3 times 7, 21 x squared plus 2 times 2, 4x 7, and 69 goes to 0. So since we have something in terms of u here, we can plug our value for u back in. So we'll have 11 times 7x cubed plus 2x squared plus 7x plus 69 to the power of 10 times 21x squared plus 4x plus 7. And this is dy by dx. So this is our entire derivative. You can tell that I've used the product rule or binomial expansion to try and figure out this question. It would have taken you forever. This would be a very, very high power with many coefficients to deal with. So yeah, and don't forget the chain rule can be applied to as many inside and outside functions as you need. As long as you have dy by du, and then maybe du by dt, and then dt by dx. So this is a case where you have three nested functions. you can use the chain rule infinitely, and it tends to make questions a lot simpler, especially when you just need to remember that you're just multiplying the inside derivative by the outside derivative. I always like to set up my equations with let's say 2x squared plus x and raised to the power of 3. I always like to set up my equations when looking for dy dx by starting off by stating what is my y. My y is, let's say, u cubed. And then, what is my u? My u will be 2x squared plus x. And from there, you can start finding your dy dx, which will be equal to dy over du times du over dx. So once again, I find it really helpful to split up your equation, and you don't have to write let, but that's basically what you're doing. You're letting the inside function be u so that you can handle the term much easier. Okay, and that's all for this video.